Okay. Great. So welcome everyone again. We're starting on time because we have a lot of material to go through. We will, by the way, monitor the chat. The chat is open for questions or comments, and we always have either Joe or me then looking at this and maybe answering directly, or we can take it up in the workshop directly, right? So this is the Good Software Engineering Practice for R Packages workshop. And quick disclaimer, as always, these opinions are ours and not necessarily those of our employers. Okay, very quick introduction about myself, and then we continue with Joe. So I did my PhD in Switzerland, in Zurich, on basic model selection. Then worked as a biostatistician at Roche for 5 years, then was at Google for almost 2 years, and then was back at Roche for the last 4 years until the summer this year, and then co-founded Arconis this summer, working now there. And I published multiple packages on quantum bioconductor, and there's also a book if you're interested, and I'm chairing Open Statsware, and I think we have a slide on that as well coming up. So yeah, feel free to connect with me. Joe, over to you.
Thank you, Daniel. Hi, everyone. Welcome to the workshop. My name is Joe, and I did my PhD in statistics, and then carried on with a postdoc at Oxford for statistical genomics for 6 years, and then joined Roche for another 4 years. And I currently I spent most of my time developing NAS packages, and some of you probably use in your daily work as well. And a lot of this work were started by Daniel as well, and it's really great we can work together to help you with this workshop. So yeah, please feel free to connect. Thank you.
Great, thanks. Okay, so let's continue. Yeah, exactly. OpenStatsware, quick word on that. Have a look at openstatsware.org. Now exists more than 2 years already, so it's a working group associated with the American Statistical Association Biopharmaceutical Section, so ASA Biop, as well as the European Federation of Statisticians in the Pharmaceutical Industry, FSPI. And currently there's definitely a lot more than 50 already statisticians. This is an older count from more than 30 organizations. And what do we do in this working group? So we engineer packages together, and we also spread the word about best practices for package building, and that's where this kind of workshop material actually originates from. So what you will learn here in this 3 hours of this R Pharma APAC workshop, we will look at the basic structure of an R package, how to create your own R package, learn about the professional package development workflow, very important, and then in particular learn and apply fundamentals of quality control for R packages. So specifically clean code routes and writing tests, very important, and then also learn about the publication, so how to make an R package available to others. So we're here in the introduction outline, and we will follow then on with the R package syntax and so on, structure, then the workflow. Then we have a short break, a 15 minutes break in the middle. There I will maybe try to fix my camera. And then we will continue with the package quality and the publication, and then we will have a short conclusion. So a lot of material. Again, please ask questions in the chat. And we will also have some kind of surveys in the chat for you to participate. So the website is important. So here we have the long link with all the slides. You can actually have a look at this short link, https://tinyurl.com/3st8rvkn. So please hop over to that because there you will have all the materials, and you can click on all the links. In particular, you can click on some of the download links for code examples and so on. So that will be very useful to go to. Okay. So maybe Joe can also put this in the the chat as well. But yeah, please make sure that you have this open in your browser. Okay, and all materials here are under this open source license that just requires attribution of the original authors, CC by SA 4.0. Okay, so what you will need, actually Git you don't need in this one, in this workshop. We had this from some longer versions of this workshop still here. So you can use a local R development environment. So with RTools R and RStudio IDE we're using here now. I think Joe will show you later. You can also use Posit Cloud. We just got some setup details for that sent over just today. So Joe will go into detail later. And then there's a quick installation script that you will need to run just to install a couple of packages that will be needed. Okay. Yeah, so of course it's good to be curious. So please be curious and ask questions. And yeah, positive attitude is always good. Okay, so now some interactive part. We make this now in the chat. So it would be great to hear from you, maybe your name and the motivation for participating in this workshop. So basically, what would you like to learn here today? So make this a bit more interactive. You can put this now in the chat. Okay, and then we have a look later, and then we can hopefully also pick up some of those topics that you mentioned throughout the workshop. Okay. So I'll just let you enter that information, and we still continue in the meantime. So what do we mean by good software engineering practice for R packages? So we want to apply this good concept of good XYZ something practice, so good clinical practice, good manufacturing practice, and now we have also good software engineering practice. And very important, there's so many packages, but of course, not all of them are good or long living. So we really want to improve the quality and longevity of our code and packages here. This is not a universal standard. We share our perspectives here. So it's really a collection of best practices. And now we have, I think we showed it somewhere, but we have given this workshop now already almost 10 times or so. So a number of times since last year or the year before even. I forgot. Yeah, so it's already matured a little bit, and of course we want to also learn from you. If you have any ideas, questions, please put in the chat. So why do we care about this? As mentioned, R has a powerful but complex ecosystem with a lot of packages, and you as the users and contributors it's good to have a good understanding of this R package, structure, even to just assess the quality of packages. And of course, we see more and more complex scripts and programs needed, and that's why we need to care about the quality of all of this and the longevity. And of course, many of these concepts are applicable to other languages, in particular Python and Julia, which are also used a lot in data science. So what can be a typical motivation to start building a package is it's when you really want to go from a script to a package. So you notice that you use some scripts over and over. So you will start by encapsulating the behavior of your script that you reuse over and over into some functions. So that's the kind of first important step, and we assume actually here that you already are familiar with R code function writing. And then you would also need to avoid global state variables that you maybe used in your scripts before. So in particular, you kind of avoid library and require statements, and you then actually use import statements maybe, or you directly just access the functions from the namespace. We will see later how that works. And you will adopt a consistent coding style, so you kind of clean up your code, and we will have a look what that means. Documentation, we will talk about that, how you document your functions, how you make sure your functions work, also over time by adding test cases. And then you can, as we're doing that, cleaning up the functions. You might also then refactor the functions, maybe chunk them up into smaller pieces that are used together, and then you can optimize the code. You also need to version your code. We will talk about that, how to do that with the package, and then share in the end as a bundle, which is then the R package. So that's kind of a little bit like a timeline, how this often works when you start from a script. But of course, don't worry, we'll go into much more detail on all of this, but cool. So this is just a fancy network graph or something to show that there's so many packages. And of course, many of them are used, not as many as the few that I mentioned here. So these are kind of more connections with other packages, but it's overall a huge success. One of the pages that you might have seen already is the Pharmaverse, pharmaverse.org, where you can find a lot of handy packages for use in pharma and clinical trials, etc. So please have a look if you haven't seen that yet. So why is this kind of important that we now apply this good software engineering practice to our R packages? Again, we will probably only get the important packages by building them ourselves, and nobody will kind of do it for us as a kind of present. So the idea is that with organizations like Pharmaverse and OpenStats, where we kind of share the burden of writing these packages together. We also make sure that, for example, if we have some new innovative statistical methods, that we kind of code them as open source packages so we can reduce the risk when more people from more companies look at it and look if everything is okay and so on. And yeah, importantly, with these R packages, we make our code testable, right? So it's also connected to this validation topic, so CFR Part 11. But also, of course, we can reuse then the code, we can share the code, and it's much easier to document than with scripts. Okay, any questions in the chat at this point? Okay. So then let me just quickly look at the chat. Any questions? No, I don't see the questions. Okay, good. So then we will just continue with the second part slides here. Okay, cool. So this is the kind of basic part. Okay, so what are our packages and how are they structured? What's the kind of syntax we need to follow? Okay, so what I assume that you know already is that packages provide a mechanism for loading optional code, data, and documentation into your R session. A library is a directory into which packages are installed. Okay, so how does this kind of work together? So when you call install.packages, then you actually install packages from a repository, usually cron, it could also be another one, into the library, right? And with when you call library, then you load and attach packages from the library to your R session. And here attaching means that the package is put into your search list. And that means objects in the package, so typically functions, can be used directly. So just about the wording, remember the package is not the same as library, but of course they relate to each other like this. So what we want to talk about now is really how to write, build, test, and check your own package, right? So really starting from the basics, how to do this in a methodical and sustainable way, and give tips and tricks based on practical experience. So again, interactive part. I'm curious, so how familiar are you with R packages? So please enter in the chat 0 if you have never written an R package. 1 if you have written an R package but never submitted to cron, so something for yourself. 2 if you have written an R package and you submitted to cron. Just to get a little bit of feeling for the experience here. So I see a couple of 0s and 1s. Very good. So quite a few 1s, some 0s, but no 2s. so far? Okay. Good. Yeah, thanks for participating. Very good. Okay, continue this. So let's talk about what's in a package. And even for those who have written a package, this might be very useful. Some things are interesting to think about a little bit. So what is a package structure like? It's basically a directory with files and subdirectories, and that's more precisely that's kind of the package source, right? That's not the tarball that you can submit to cron. That's not kind of what you download from cron or so, but that's really kind of the source directory. So what you definitely have in your package directory is the description file, the namespace file, the R folder, and the man folder. And we will go through all of these, of course, in detail. Typically, but not always needed, you have data directory, inst directory, source directory, test directory, vignettes directory, and the news file. Okay, and we will also touch upon those. Okay, but just to say there's a few things you need to do that. You need to have those, otherwise it's not a valid R package. And there's quite a lot of things that are optional. So how to get started quickly with this? Okay, so once upon a time, okay, when I started programming in R, I needed to set this structure up manually. So that was very boring. Fortunately, nowadays it's super fast. So you either use the use this package and with the create package function, or in your RStudio you just go to file, new project, new directory, and then you create a package. Okay. So let me quickly show this because we will anyway do some other stuff as well. So hopefully you see my R console. Otherwise, Joe, let me know if not. But yeah, so you go to File, New Project. And then you say New Directory, for example. Then you say R package. And then you can already give it a name here, right? Test package. Here you can even say you want to base it on some source files, but we don't do that here. And then I put it somewhere. For example, here we could also try to use rand. We will not touch upon this a lot to keep track of all the dependency versions. You could also directly create a Git repository. We're also not doing that here. So we are really focusing now on the fundamentals of the package. Okay. And when you do this, then it takes a little while, but hopefully in the end we should be there. And of course you can do this in parallel if you like in your RStudio. And maybe Joe, if you want, you can also share the Deposit Cloud link as an alternative for people who have not the local setup. Right? So, but you see already here, so now where we are in this a new project here. Here's the RStudio project file. That's not a part of the package. That's really RStudio specific. But then we have here these 4 things that I mentioned as mandatory, right? We have the description file, the metadata of your package. We have the namespace, the exports and imports. We'll look at that. We have the R folder here with the R files. And we have the man folder here with the documentation files, okay? And now we will go through those in detail. Okay, you see, very easy. Now let's talk about the description files. Description file. So that's very important because, for example, it defines the name of your package, right? So you need to choose the name of your package. Here, what did I have here? I just had test pkg. So maybe that's of course not a good name in reality, right? So it's not unimportant. And you also, if you aim for publication later, check if your name is still available. The title of the package, that's kind of like a title of a manuscript. So use title case for this. So let's say, for example, if I go back here, I would something like this, or I can say test package for my workshop or something. I try to use the title case. Right? Then the version, usually you start with a low package version, so something like 0.0.1. And then you basically have this syntax, major version, minor version, and patch version. So if you just have a patch, you just increment the last digit. If you have a minor update with new features, you increase the middle digit. And if you have a major new version, for example, it breaks backwards compatibility or something like that, then you increase the major version. Or maybe also for the first completely full version, you could say 1.0.0. Okay, so that's pretty clear. Again, here we had 0.1.0. That also works, and then we can definitely version our package. Then in the authors at R, you would add the authors and the maintainer. Okay, so actually here we don't even have this proper syntax, so we can try to change this here. Let's actually quickly see if we have the use this package is doing something like this for us. I'm not sure. Use author. So you can use this package here with use author, for example, and I can add myself here. Let's see if this works. So what is it saying now? Use this. Found legacy author or maintain. Exactly. That's a kind of a legacy format that you just have author colon, right? That's the old one. We recommend one of these ways. Delete, convert. Do you want to cancel this operation? Sort it out first. Yeah, I mean, in this case, I just need to sort it out first anyway. So we can basically here first delete this one here and also delete this one here. Okay. And then we can do it again. Oh, empty lines found. Okay, then we remove the empty line. So now we have a nice here, nice authors at R field. Okay. So very, very useful here. And we could now also here change the roles. So I think that also is here. And we could, for example, say the role is creator and what was, let me come back to the help file quickly. Use this, use author. So because it's sometimes, so when you like me sometimes forget about the abbreviations here, right? So look at the help file here for this one, and you can see, that's usually auto creator. So when you are the first one for your package, and you are the maintainer and the author, then you put these two roles, right? So here we don't need to call now anymore the use this function. We can just edit it directly. So creator is the same as maintainer. Okay. So then we can do like this. And then the cool thing with this also the R field is then you can add more. You can add more authors. So for example, let's try to add here Joe as well. You see what it did? It created like this kind of vector here. It's really like almost like R syntax. And then he added here Joe. And then if I want to have a different role, I could also do that. Joe already appears. Yeah, okay. We can direct it and change it here. Okay, yes, of course. Right. So that's the authors at R field. Okay. Description like an abstract including references. Yeah, we have basically multiple sentences here. Okay. That's clear. License, that's important for open sourcing. In this case, we don't, we just have this kind of stub here. And that also works with the uses package. I think we will see that later. Depends is very important. So on the one hand, it defines which R version users need to have at the minimum. Okay. So we actually don't even have that here yet. Let's see if we also can do this with the uses package. Depend, use latest dependencies, use version increment. This was for the versioning. Interesting. Use latest. No, so doesn't seem to be like the very good support here. So basically how it works, you just write depends, right? And then you say R, and then you say greater equal, and then you say the minimum version that should be used. So in this case, because I'm developing this on 4.4, the kind of safest thing is to just say it needs 4.4, right? And then what else do you put here? Ideally, you shouldn't put any package here, actually, because what happens is if you put a package here, those other packages will be loaded and attached when you actually load your package. So that should only be very few packages, if at all, right? Of course, if you write like a, I don't know, ggplot extension, ggplot2 extension package, then you probably want to have ggplot2 here in depends, because your package will only ever be used with ggplot2 inside it, right? And then you would, for example, say here ggplot2, and also usually try to use like a minimum version, right? And then again, a safe way could be if you develop it on some version of ggplot2, first check the kind of version. So I think we have this package version command exactly. That gives you the version of the install, and then I would say, okay, here, greater equal to 3.5. Okay. I just usually don't give the minor, the patch version, but just up to major minor. So this is depends, okay? Similarly is the imports field. Okay, this is the packet, you put the packages from which you import functions, methods, and classes from, right? And that basically means what you kind of need inside your package, right? So let's for example, I don't know, let's say for example here we have a hello statement, and for some reason, I don't know, we want to have here ggplot. Oh no, not again ggplot. But for some reason we want to um, maybe do some data manipulation with dplyr or something, right? Of course, maybe not the best example here, but then you would basically first use something here and from dplyr, right? So let's say, I don't know, we just have some data frame. Just making up some example on the fly, as you see. And then we do, I don't know, dplyr, mutate, and then we have another column or something, right? And then we return a data frame. So it's kind of a strange hello world, but okay. So we have some data returned now. Okay, so now I'm using here this mutate function from dplyr. Okay, so I need to declare this, and how do I declare this? I basically go here in my description file, and I say imports, and then dplyr. And again, the safest way would be to check what's the version of dplyr that I'm developing on, 1.1.4, and then put this kind of 1.1 here as a minimum, right? So this is kind of when you really want to use functions from packages, and that's kind of the usual way that there can be quite a lot of packages here in imports. Of course, you should try to minimize this a little bit, not import every and each package under the sun here. Maybe we will come to that as well later, but when you need something, do like this, right? And then last but not least, suggests, right? These are packages for documentation processing, so Oxygen 2, we will come to that in a second, or running examples or tests, for example, test that, we will come to that, or vignettes. Okay, so we will see that later. So these packages are not needed to actually use your package, but more like suggested if somebody wants to further develop the package, for example. Okay. By the way, any questions, just put in the chat. Huh? Okay, so our folder, second important component, right? So we covered just the description file. That's the metadata for your package. Okay. Now we look here into the R folder. Okay. It can only contain R code files, and it's recommended to have this use the dot capital R suffix and not the dot lower R suffix. Of course, we can create this with use this, but we can of course also create this just here. Click here in RStudio and then create R script, right? Right, you can just create a file like this, is clear. And then what happens in these R files? In these R files, we assign R objects, and mostly this will be functions, but it could also be constant variables, data sets, etc. Right? So as we already saw in this hello.r file, we assign a function hello. Right? That's what's happening here. Right? Yeah, and by the way, these shortcuts are also useful here, but we don't need this right now. So we just remove this. Okay. Important is that this code in these R scripts should not have any side effects. So avoid any kind of require options, etc. So what is not good, or what is kind of forbidden, that you put here some kind of require statements, right? So for example, this would be wrong, because instead we have this imports mechanism, right? And you also don't want to set some global options here or something, right? This you don't want. Okay, and then one interesting thing is if certain code needs to be sourced first, then you would have a way to specify this on top of the file. For those who are familiar with C or C++ or something like that, it's very similar, like in those languages where you include certain header files. Make sure that certain code is available. And here you basically use this kind of Roxygen2 tags, this add include tag in particular, to then say you need first to source the code in dependency.r before you can source the code in this file. I will not go into more detail. This is mostly relevant if you work with object-oriented frameworks like S4 classes, for example, where this is relevant. Otherwise, this is usually not relevant. Okay, so now we looked into the R folder already. Now let's have a look at the namespace file, okay? So namespace file, as mentioned, we have it currently populated like this here. Basically, we currently export just everything according to this regular expression pattern. We will change this later. But in general, what this namespace file is doing, it's defining the namespace of the package. That is how to work with R's namespace mechanism. And you basically say which objects are exported to users in other packages, so which are usable by others. And on the flip side, which are imported from other packages. Okay. So that's important that we will have a look at that. But yeah, maybe I can already mention something here. So one interesting way maybe here is, right? So it can be a little confusing, but basically I would always recommend, if you want to use a function from another package, do like this. You put your package that you need here into imports, and then you access directly the namespace of this package with this package : syntax. Okay. However, an alternative way is the following. Okay. If I don't want this package : thing, I can also say I really copy this this specific function from the dplyr namespace into my packages namespace. Okay. And you can write this here manually, but we will see that we will not want to do this. So you can say import from dplyr mutate, right? And then you copy this mutate function from the dplyr namespace into your namespace. And then you can use it like this directly. So that's basically the import. And export, we could, again, we will not do this in 5 minutes anymore, but we could export a function. So we can say hello should be part of the user interface, so part of the API. Okay, just putting this here as a reminder. This is an alternative if we really import this function. Okay, so that's what's in the namespace file. And why is it important, or how does this work together with the usual use of R? Just briefly mentioning this here, but it's important because it's part of the search strategy for variables, right? So how does it work? So it works like this. You have a priority of the variable search. If R encounters a variable name, it will first look in the local environment, right, in the local scope. So that's typically the function, like the function's body, etc. So for example, here, I define here a variable df, right? And now I'm using this here in this line 4, I'm using df. So how does R know that it should use this df and not maybe some df that's defined somewhere here? It knows it because this is the kind of first priority. That's the local context, right? It's a local scope. It's this local curly bracket here. That's why it will use this one, right? If this was not here, it would go back to this one at some point, okay? And the second priority is actually the package namespace, right? And this is important because if you have multiple functions and you use them with each other, right? So for example, let's say we have hello2, and for some reason I'm calling then hello from here, right? Even if there's other hello functions in other packages, or the user has defined a hello function and so on, it does not matter, because the second priority is if there is something in the package namespace, which there's a hello, then it will directly use this one because it's in the package namespace. Okay. So this is different than this local thing, but this is because this is in the namespace. So even if this is in a different file, right? So even if I'm moving this one here, it would still work. Okay. It will still work because hello is in the package namespace. It's part of the package. Okay. And after that come imports. So for example, here, this dplyr mutate is an import. So that will be the next priority, third position here. Then comes the base namespace. So anything that's kind of available in base R, right? And then comes the normal search path. And what does it mean? So when you basically enter in your R console search, then you see the current search path. And how does it look like? Of course, we start with the global environment. That's basically what you have, you know, in your session. There's nothing at the moment here, but if I define some variable, then I have something. Right now, I have an object A here in my global environment. Next come the packages that the user has loaded. So before, remember, I think I loaded here ggplot2. So that's why it's here. Now we have here RStudio because it's in RStudio. And then comes here this kind of base packages. Okay. And you see, yeah, the kind of basic packages, and at the end comes here the base package, right? So yeah, but you see the base namespace even comes actually before that. So it's kind of a bit confusing here at the end. Yeah, and why do I mention all of this? Just to give you a feeling why the namespace is important. Okay, usually you don't need to worry too much about this, but that's why it's important. Okay, so so what did we cover so far? We covered the description file, the namespace file, and the R folder. Now comes the man folder, and you see currently there's this hello.rd file here. Okay. Looks a bit like LaTeX syntax for those who remember this. Here, all user level objects should be documented. Okay, internal objects. So that means objects which are not exported don't need to be documented, but I would still recommend it. And once upon a time, you would actually manually edit these RD files. Okay, you would manually go here, edit this, similar what I showed you, manually edit this one here. But this is also very boring, and you can make a lot of mistakes. So fortunately, nowadays we have Roxygen 2 already for a number of years, almost 20 years we have that already. So that's the way to really go forward. And how does it work? Works by including the documentation source directly in the R script on top of the objects we're documenting. Okay, this is very similar if you know Doxygen, for example, for other languages like Java, etc. very similar like that. That's always it's called Roxygen. And the syntax is composed of these special comments, this hash prime combination, and then special macros preceded with the @ sign. And then now Studio will be very easy to render to produce these artifacts in the namespace file automatically. So how does it work? We start with this command here. So use Roxygen MD. So I go here. First of all, I want to actually delete my kind of manual namespace file because we want to overwrite that. Otherwise, we'll have some error message later. And then I'm just going here to my terminal and put, I thought I copied this thing. Anyway, use Roxygen MD. Okay. And then what did it do? It edited here something in the description. So you see, it added here this Roxygen. So that's what it did. And now we should run DevTools document. So let's try to do this by just clicking on it. You see updating documentation, loading, test package, writing namespace. So now we actually wrote the namespace, but there's actually nothing in there. So if we want to put something there, in particular, the things that we had before, we would, for example, put here the special hash prime combination, then an add export for exporting this hello file. Okay, and now if I say again, I can go here, build more document. Oh, I cannot do it yet. Exactly. I need to first configure the build tools. So configure build tools. It was maybe a bit fast. I'll show you again. Build more configure build tools. Okay. Build more configure build tools. And you click here on generating documentation with Roxygen. And then you just say, okay. And now we have here this document thing available. So we can also execute that with this handy shortcut, Control-Shift-D. Okay, and when I click on this, it will again update things, in particular the namespace. And now you see, now I have this export hello here because I had this tag here. Okay. And again, similarly, if I wanted to import a specific function, which for normal functions, typically I would not recommend it. For methods, for generic functions, you actually need to do it sometimes. So let's say we want to import, and you see we have already this kind of tips here, import from dplyr mutate. Right, and if I do this, then I can basically don't need this line anymore, but I can directly use this line. And I can do Control-Shift-D for running the documentation. And again, it's updating the namespace, and now I have the line that I manually had in my old namespace file, right? So that's kind of the magic of this for updating the namespace. And this we just did. Okay. And now the other cool thing is, of course, for the documentation, right? So let's have a look what we have currently here in the man folder for hello. There's actually still the old stuff, so we can actually delete this. Okay. And now we can come up with some proper documentation. So let's say here, code, insert Roxygen skeleton. Oh, it doesn't work probably because of this. Let's put this here. So normally when you're in the function body, it should work. So you go to code, insert Roxygen, yeah, exactly, skeleton, and then you get this kind of starting point. And then you say something here, hello world function, hello world, or something, and then you give here some description. This prints hello world. Or this prints a hello statement and returns data frame or something. Typically, you also put here in this return, you describe more in detail, right? A data frame. And you see, I would put this here into backticks because I want to have this in code formatting later. A data frame with columns A, B, and D or something. It's really not very useful, but okay. And then we have an example. Then we can even save this or something. So this is how it works, right? So, and now comes the magic. Now, when I say build more document or Control-Shift-D, then it's also writing this hello.rd, okay? And if I actually just click here, it's directly rendering this even for me. So it's very, very nice in RStudio here, very easy. But I can, of course, also look at the file directly. And you see, this has been generated by Roxygen, do not edit by hand. And this was all generated by Roxygen, right? So that's pretty cool. And as you see, it's very easy to maintain because it's directly above your function. And you cannot, yeah, it's more difficult to forget to update this when you update this and so on. Okay. So this is just the same basically as mentioned here. Okay, now comes the optional folder. So we basically covered all the mandatory stuff now, right? This is the bare minimum what you need. What you should have, and we will talk more about this in detail, you should have tests for your function, okay? So how do we get started with this? And these come in the test folder then. We execute this use test that from use this. So we say use this, use test that. And you see what it's doing. It's again doing something here with description file. We now suggest test that. And we wrote this tested.r in this tested subdirectory. So first of all, we have a tests folder. Here, basically, any kind of scripts that should be run during the testing can be put, right? So sometimes you need to go out of the test, outside of the tested framework for some reasons. Then you can also put some test files directly here. But in principle, you have to structure that most or all of the unit tests are basically untested. They are called basically by this tested.r script, right? So typically, you don't need to modify anything here. And you just put new tests into this tested folder, okay? But we will look in this in detail later, so that's why I don't go into more detail right now. So data is a bit similar. You can ship data in your package if you need to, so basically example data, okay? And we can use this use data command. Yeah, typically, yeah, I can quickly show you how this looks like. Use data. And yeah, the thing is you already need to have the data kind of ready here, right? So in our case, we just have this very stupid A value here, but okay, we can put this. So now that it will create a data directory for us. So if we go back here to the root, we have a data folder, and then we have a file that's basically the same as the variable name or the data set name .rda. So it saved this thing to the data set. Yeah, there's one question. Do you want to enter the question in the chat? And then we can go with that. Okay, cool. So and then the next step will be documenting your data. Okay. So I think we might have something. No. So we don't unfortunately have this here. But what you basically need to do is you need to write something similar. Right, so you basically have in the R folder, you can have like an R script, like data or something. And then you would basically have this, you would, for example, typically have just something like this, A, and then you would have a description of your data set, right? Strange data, and then more details. And then you can actually look here, this very useful link here for documenting the data sets from the R packages book. And here you have some kind of nice kind of how-to information. So typically you have a title, you have a description, then you have a format section, okay? So where you typically say what it is, so kind of what class it is, for example, data frame, how many rows, how many columns, for example. And maybe also you can give a source. So this is kind of the way to do it. And then again, with Roxygen, this kind of stuff will be automatically compiled. So I'm not sure if I maybe now use it here. we might get an a.rd exactly. So now we have an a.rd, and we have this format was even automatically done. You see, if we don't put format ourselves, it will kind of infer it automatically. So very easy. Cool. So we're making progress. So this was data. There's a more specific thing if you actually have simulated data where you actually have an R script to generate your data. Then you want to put this into the data raw folder. There's another use this command for this. So then you basically want to have a folder in your repository. It's not part of the package, but it's part of the repository where you save these scripts. Okay. So, but we don't show this here. It's relatively specific. Inst folder. Any kind of thing that will be an inst that will be copied recursively to the installation directory in the library. So be careful not to interfere with any standard folder names. So again, how does it look like? So you would basically have here in your root, you would have a folder inst, right? And anything I put here will be available in the installation then later. Okay. So for what is this useful? So for example, data that is used by functions in the package itself, but not directly for the user. So then you would, by convention, have an X data subfolder, and then you can load this with the system file command by just saying it's in my package, right? And then you can say it's an X data slash something. So that can be quite useful. Also, if you want to have a custom citation output, so any kind of package has the citation command output. So for example, if I want to look at the citation for dplyr, I can call it, right? Currently for my package, I would just get a kind of default. Yeah, I would also get some kind of default like this. I think this is actually a default. But if you maybe have a paper with some statistical method publication, then you want to put it there. And you can actually create this with this use citation command. So let's try this out. Use citation. And you will see what happens in the inst folder. It's creating a citation file. And now we have a bib entry here, and we can put all of the details of our, for example, paper, right? And this will then be used for when somebody calls citation on your package. So this can be very, very useful. Okay, remove this again because we don't want to fill all this out now. It can also contain additional documentation files that are already available in final form as PDF, for example. So that will be the doc subfolder under inst. Okay, source folder. That can be there to contain sources and headers for any code that needs compilation. So it should only contain a single language normally here, and only because R uses it directly, you might be able to mix C, C++, and Fortran code, which usually works with operating system native compilers. That's more or less as much as I want to say here. It's definitely much more complex to write and maintain than an R-only package, right? And typically only makes sense for either wrapping existing libraries for use in R that you basically don't want to recode in R, or if you want to speed up complex computations. So we have a separate chapter, not today, but in longer versions of this workshop, which talk about that. But basically there's RCPP that you can use for this kind of stuff. But yeah, not for this kind of basic introduction today. Vignettes are much more important, much more often used. So vignettes are special cases of documentation files, PDF or HTML format created by compiling source files, right? Important here to note is that package users actually don't need to recompile the vignettes. They are delivered with the package directly. So how do you start with writing a vignette? You use this. So you say here, use this. You search for vignette and you say use vignette. Okay, I need to put a name. For example, introduction is always very useful. Right, it's doing a bunch of things, right? It always describes it very much in detail, which is very nice. And we end up with this introduction.rmd file that sits inside this vignettes. I'm getting, sorry, somewhere else. That sits inside this root directory here, right? So now I have this introduction.rmd, and I can just happily start writing my my kind of introduction, right? Introduction to my package, blah blah, right? And actually, if I configure the build tools accordingly, I can also use Roxygen to generate this vignettes. Okay, so now when I say build more document, it should also compile the vignette, and you see it's rebuilding the introduction vignette, right? And now then it's completed. So this is kind of how it works. And how would I actually see that this kind of does work? So let's say let me show you the full thing. Let's say we do here an install, right? So not just always document and so on, but let's try to install the package and let's see if it works. Something doesn't work yet. Oh, we have, okay, it's already complaining here because we don't have an email address. Okay, so let's put the email. Let's see if this helps. Okay, now it can be installed. Okay, great. So now it's installed the package and it loaded it, okay, into kind of a restarted R session. And now I can, for example, say vignette introduction if I'm lucky. If I'm lucky, it's coming up. Oh, but this is actually something else. Yeah, you see, it was actually found multiple times. So I have to say here which package I'm looking for. And I called my package test package. So it didn't quite work yet. So I think we need to do something else. Maybe I excluded the vignettes from the builds. Let's see. Use. Maybe we also click this one. Clean and install. So usually, yeah, sometimes I have this problem, but the good thing is when you then let's try again. Probably does it build the vignette updating vignettes? Yeah, I'm not sure. Otherwise, we come back to this. Okay, let's come back to this later. I'll need to fix this in the when Joe is doing his part. But yeah, usually this is how it works. And the cool thing is when you submit the requirements on, then usually everything works anyway. And when you have it on GitHub pages, we will also see that later. Yeah, but it's very important for the user to understand the high-level ideas. So you put some kind of high-level introduction there. Also some kind of documentation of your statistical methodology, for example. And it complements this kind of function level documentation that we had looked at before. Okay, trying to wrap up. So a news file, also very important. You basically want to list the user visible changes worth mentioning. And you can also start this with this use this command. So very, very easy to do. It's relatively clear how to do this. And then building the package, as mentioned before, the first step is documenting. We did that a couple of times already. Then, of course, you would run the check, right? So how does it work? We go here to build more, build and then check. So that will start the typical R command check stuff via this DevTools wrapper. And we will get a lot of information, what works and what doesn't work, and if there's anything we can or should improve, right? Let's see how it looks like in this case. And you see it takes some time, and of course the larger your package is, the longer it will take. And you see it's actually using local language, so I have here German. That's where you see some German popping up here. Yes. So we see a bunch of things that we will still need to fix, right? And then you can basically go through these nodes and problems one by one, right? And make sure that you kind of get things clean. So for example, in this case, what did I have here? There's first some problem with the license because I have this question here. So this is something also to use. This package can be useful, but let's just remove it for now. We don't need it for now. If you don't want to publish, you don't need the license. And then it says all declared imports should be used. So in this case, so it's basically saying that we don't use the deployer thing even though we imported it. Let's have a quick look. Why is that? What type of mutate we have here? Okay. Package and imports field net are not imported from. We don't have it. Because I don't have the import yet. Yeah, so you see in the namespace, I don't import anything, right? Here. So yeah, sometimes we get this problem. Then you basically just need to import something. And this is not executed here because it's not on top of a function. So we actually need to put this here. Then it will work much better. Okay, this was a mistake before, but of course in reality you will also make mistakes. So it's good to get into this workflow that you write something, you test it, and then you fix things. And do this rather often than more often than less often. So then you will quickly see the problems. Then you will have your package and depends not imported from. Yeah, exactly. So that's I forgot to mention that before. So basically, whenever you have something it depends, you should actually also put it into imports because that's relevant there. Okay, so then we can fix this just by putting this one here also in the imports. Okay, so this will fix this one. Then we had the bug here with the mutate. That was only because we didn't have the import from in the right position. Okay, this should then hopefully work again. Then of course also the example failed. So now if I quickly want to test this, I don't need to install. I can just run documents, right? And then I say build more, load all. Okay. And now I just try if for example, I can just interactively try if the hello function works. Okay, and that seems to work now. So it's much better than before. Right, and then I could rerun the check and so on, and improve things from there. So this builds more document and build more load all kind of steps are very important. You will run through these very often. Okay. Good. And then last but not least, when you want to build a package, there's the build source package menu command. So it makes it very easy to share the package with others, submit it to cron. So let's do this one time, just because it's kind of connecting back to the idea of a package, right? So why is it called package? Because you can build it into a single file, right? So I can here say build source package, and then it will do that. and it will produce the single file. Okay. So just takes a while. So you see, now it says here building this. Okay. And now here I have this test package file. So it's a one single file, 5.2 kilobyte, very small. I could now send this by email to Joe, or I could submit it to Kran. So this is how we can share this in principle. And we could then install it also from there, right? I mentioned the build more load all already. Okay, good. So I hope you already went through this as I was doing it, because we need to continue already with the next slide. So we have a packed program. So I'm handing over to Joe now for the next part. Yes.
Right, so this is the POTSA website, and you can click on this link to make a copy. And once you make a copy, there's like 13 people already made copies, and yeah, you can carry on your work there. So let's go back to the slides. So not this, yeah, our package engineering workflow. Right, so okay, we're gonna speed up a little bit, and there's quite packed materials here today. And so motivation from an idea to a production grade R package, and mostly it's all about reproducibility and making things all packed and reproducible, and to make it shippable, and it's easier to work for other people as well. And for a professional workflow, imagine you're in a factory and there's a certain protocols you need to follow, and to making things easier. There's a good practice and bad practice. And today we will just introduce something that from experience we think they are good practice that we would like to recommend you. So a typical workflow start with idea and concept creation, and validation planning, and writing down the specs, and etc. And what you can see here is from step 1 to 4 is actually like all about planning. And the R package programming, the writing code is actually just a small piece. It's in the whole workflow. This is an important piece, but this is just one piece. And then after that, after the programming, there's also document creation and completion of formal validation and package release and making production, etc. And then when the cycle goes through, there's also like a maintenance at the end. So how we do it in practice? Frequently used workflow in practice. So this is something. This is not just saying, hey, this is bad, and like, but this is something that people often execute software developing like, right? So you have an idea, and then you start programming. So immediately when you have an idea, you start writing down the code, okay? And then you release the code, and then make it in production, and then very soon there's a box, and then you start fixing, and there's you release again, there's more bugs and more documentation, and you probably say, hey, this is breaking change, etc. And then using production again. So this is kind of like a pretty bad cycle, and then you spend a lot of time on the maintenance. And of course, like in the package development, there's like a development and the maintenance. For a software, after you release it, a lot of work is after that. A lot of work is maintaining, but you want to manage the maintaining work, whether it's overwhelming or it's like a very little, and it's actually maintaining, just like adding little things. So why good practice is important? So what you see is like a normal life cycle of like a programming is about you spend lots of time designing and coding and testing, but then majority of time of maintenance. And regarding the maintenance, there's like a different errors, and there's a different type of errors. So like something like analysis errors and design and implementation errors. And you probably see, hey, what do they mean in practice? Like design and implementation errors. So when you're doing some programming, there's always some people don't understand what maintenance mean. So let me give you a simple example. Let's just consider if I want to ask you to program 1+1, and you say, hey, it's easy. It's 1+1 is equal to 2. And then you say, hey, I want to make this more generic. And so like A plus B. And then later on, you find out A and B can be integers, can be floating points. So it start become like a more complex. And when your memories are when you set it to integers, when you're adding two numbers together, sometimes it gets error, and because it went out of like the integers of space, so it goes to like other things, go to -1 or something, and which is not possible, and or it just give you errors. And then if you say, hey, A plus B is equal to something, and then if you start doing something like a floating point, and then you start looking into, hey, the the precision, and sometimes like because the floating points are like not exact numbers, and they're not real numbers, and so when you're adding two things together, what you see in computation is actually it look a bit different. And so that's why maintenance is that's why like people keep developing and keep adding code, improving your code. So why practice good engineering? And is so don't waste too much time on maintenance. So and then what you want to do is like do a lot of like planning ahead, and yeah, don't waste time on efficient and buggy further development. And sometimes when it's not good enough, and just like redo the whole thing and then restructure the things. And don't be afraid of tearing down things, but sometimes that also adds like a more time, and so it's not it's not recommended you always tear down things, but it's don't be afraid of like tear down things that's it's just like inefficient and buggy. Right, let's keep going, and yeah, invest more time in software design and architecture. So that's more important. And today we're gonna do some examples together, and then yeah, cool. So suggestion for a workable workflow. So idea and the starter design document. What does I'll get into the details for like design documents. What does that mean? And today and in this session, we'll talk about our package programming, and just like I give you a very simple example from designing documents and to some like a function creating and writing down in the package. And Daniel has already gave like an excellent example on like all the names, all the folders and all the things like you need in the R package, and we will follow that as well. And as today, what we say is a good practice, like and we will rely on using a lot of existing tools to facilitate us to speed up. And there's like because the community is growing, there's like a lot of excellent tools and has developed and to help us to do this work. For example, what you've seen before, Oxygen 2 and dev tools. And again, we will keep using these packages in the next 2 hours. Right. So let's get started, and this will be like a bit of hands-on example, and then a lot of things will be like just copying code and get things together. And right, and yes, so let's get started. If you go here and start the session, and I'll get into the session I created before, and yeah. So from this session, there's like a package is already installed. It doesn't take too long, but yeah, it does take like a few minutes. And if you start reusing this snapshot of image and things are installed already. Okay, so what we're gonna do today, there's like a simulator package we're gonna build together in the next 2 hours, in the next probably 90 minutes. And so the project, when you start the project, you start from the website where you get everything from. Yeah. So if you start from scratch, and you start from the thing, you install packages here, and you download and submit this simulator zip file to your RStudio. Yeah, and it's going to create a folder called simulator here. And what we're going to do is we're going to start looking into this package. We're going to start this project. Stop save, and we're going to start from the beginning. And the object is to create some simulator package. But as I was saying, it's very important to do design. So in the next 20 minutes, we're going to think about how we do design. And this is just going to follow the exercise in the slide deck. So this is very empty, and add examples and the descriptions. So right, we're going to start from here. Let's say what we're going to do today. So let's assume you use some line of code to create a simulate data in multiple projects. So this is the code that you need. Right. So I'm just going to copy this code here. And what it does is just going to simulate it. It's going to run the code and create a data frame. Yeah. So it's just a simple data frame, and with column 1 and 2, and the first column just says like a group and indicating group 1 and 2. And the second column just values that contains values from the 2 normal distribution with 50 numbers in each group, and with mean and difference mean and standard deviation listed here. Right, next step, what we're gonna do. We're going to identify the purpose and scope of this package, and then find out like exactly what is you must have, and something is you should have or nice to have, and then something is like maybe, yeah. So for me, and always like just keep the work to the minimal, and the must have, let's do the must do's. And the purpose and the scope for this package is to intend to enable a creation of reproducible fake data. And so some keywords, the producibility of the simulated data must be ensured via optional seed. So seed must have, right? It should be possible to print the functional results. So something is must have. The package may also facilitate the graphical representations of simulated data. So let's do some plotting, but it's not must, yeah? So start with the design doc, and that's where I started, and then in the R Markdown file, and also you could use some other options. And you need to consider like, hey, if I start designing these things and what do I need to do? So first of all, you think about, hey, I need a data frame, I need to create this data, yeah? And then let's go back to that page and say, hey, I need to do some printing and doing some printing of the function results. So what could you print? So you must have like a definition of sample size and user group and mean per group. And you probably think, hey, let's do some p-tests. Yeah, let's compare the simulated data and etc. So let's create some functions allow us to do that. And of course, you need to, what I just did was like I viewed the data in RStudio, but also you can print out this data and make it like visible on your R console. And yeah, so let's make some generic function and document all functions. So one script has a starting point. Let's create a function. You can also just copy this and paste it here. What I just did before was creating a data frame, yeah? And then I just like look at this data frame and what is there. Right now, what I want to do next is to create this function. So within this function, let's see what we have. We have a sample size 1, sample size 2 for population 1 and population 2, and we have a mean and standard deviation for each one of them. And reproducibility, what we just see before, we need to provide some sort of seeds, right, for this thing to reproduce some to be reproducible. But first of all, let's test if this thing works already. Yeah. So let's just do some testing and see, hey, same data, and I want to create 10 numbers and 10 numbers, and 1 and 2 and 3 and 4. Okay, seems working. So just create a simulate some data. Next step. Let's refactor this script. And what we want to improve. M1, M2. Anything can be M1, anything can be M2. But that's like after a while, when you come back and read this script, you want it to be like more readable. Or if you pass on to your colleagues and you want this thing to be understandable like immediately, and instead of like you actually need to run through the code and then test it. So what you could do is just renaming the variables, and so for example m1 m2 make it like mean1 mean2, and s1 s2 you make it sd1 and sd2, so it stands for standard deviation, right? And the theme.data it doesn't seem to be a very good function name, but let's like make it a sentence, like adding some verb, adding some purpose for this thing. So you don't have to write a lot of documentation, but just by reading this function name, you can already know what it's going to do. So again, we can copy this code. And I'm just going to overwrite this because I don't want what I had before. So this is refactored already. You didn't change anything other than the function variable names. Yeah. Now packaging. Let's add something into it. So what we had before was just a data frame. Yeah. But it doesn't have like all the inputs and associated with this data frame. And by just outputting the data frame, if you just pass this data to someone and you save it, and when you come back and you actually don't know what source it was used from, you probably the only information you can get from is just the N1, N2, and from like your sample sizes. And but the mean and standard deviation is it's not very visible. So what we did here is just like, again, this is where we started having this data, right? And now we're creating a list. We have this list, and in the list we provide all the inputs that we gave to this function, right? And then we save this data object into this this data frame as like a element of this list. And then at the end, we package it up. How we do that? We make it like a class attribute. So we make it and we define it as a class as like a simulated results. And then later on, we can write specific plotting functions and printing functions. And you can just say, hey, print this simulation results object, and then it's going to print this thing very nicely. Okay, next one. I see some raised hands, and yeah, Kai. Is there something you want to say? Hello?
I can check on the chat with them. I'm back now.
Okay,
I
cool.
just fixed my camera. Yeah.
All right. Thanks, Daniel. Okay, okay, I'll close this. Right, so, okay, basically this is how we how we start the design, and yeah, and this is just like if you copy the code here from this page. So we overwrite, we refactor this design documentation again. And when you run the function, you get something N1, N2, it's all listed. It's just like very flat and just like laying on the screen. And it's not very, it doesn't like, it's not very readable. I mean, it's a readable as like when you're scrolling down, but it doesn't give you like a very nice summary. So I don't think you can show this to your boss. So let's do some nice printing, okay? And okay, now that's when we do write a generic print function, and then you can provide this X. Now your this X is your simulated results, and then it's going to extract from this list with your N1, N2, and then provide your arguments, and then it's going to print out nicely with your data as a table. So what's the output is going to look like? It's going to look like N1, N2, and like in a very concise format. So rather than the previous page, it's just like laying down like in just kept printing. Now it's just everything's nicely printed in two sections. And the first section is your arguments for this function, which gives you like your n1, n2, and mean1, mean2, and standard deviation 1, standard deviation 2. And then your data. And the data doesn't actually print out everything, it only just print out the first 10 rows. Okay. Cool. Let's do some exercise together. And I think we are due for a break. And please feel free to go and grab a coffee or something. And I will be here and continuing on the tasks and the exercises. Yeah.
Yeah, and I think we will probably not have enough time to go through everything. But the good thing is we have all of these materials on the website, so you can also later go back to this, later today or tomorrow or on the weekend and have a look at these little exercises as well. Yeah, just today we don't have so much time, unfortunately. Yeah,
Cool.
so let's make a break until 22. So let's do like 7 minutes, I would say.
7 minutes.
Yeah.
We just this will be very quick, and I just want to first mention like the first thing here, assertion. So yeah, assertion is important, and so first of all, like when you're doing debugging, like when people use your function, use the code, and sometimes it may not be an error with the code, but like how it was an error, how it was used. And so you need to make some assertions to your functions to protect it. And so it can provide some useful information to the users. For example, if I say the assertion like play with assertions, and if I create a function like that, and with n1 as my inputs, and then it's going to assert that n1 is not going to be lower than 1. And if you put anything that's like a negative -1, and it's going to say, hey, this assertion check has failed. So what you could do here is in the function we did just now, we could put a certain assertions here. So first of all, your sample size in n1 and n2 cannot be negative, right? So you can add some like assertion integers here and just say, let me copy the code here. So what you could do, you could just simply add into assertions here. Check your n1 and n2, and then it cannot be negative, and that'll be okay. Right. Let's pretend that I've done all this designing work, and then I have worked out like my print function and my plot function. I'm just going to quickly show you what they look like. And in the simulator package. So once I'm very happy with like the results in the design document, I could just copy and paste them into my R folder and into this little script. Yeah. From the package, we left the spaces that for you to fill out. So like N1, N2, min1, min2, and alternative hypothesis. And this was the assertion I just added before. And then I added some like checks, and then so making sure the code is reproducible, and then the codes before, right? Started with like an initial data frame, as what we've seen in the previous exercise, and then I packaged up this results into the result, yeah. And following the exercise later, task 1 and 2. Task 1 added the assertion. Task 2 added a new new variable and total, and some new results, and the creation time. So you know when the data was created, some allocation ratio as well. So that's just simply your N1 over N2. And yeah, and that gives you the function, the rest of the function. And then I did a t-test. With the t-test, I also allow it to provide some alternative hypothesis, which is like the inputs that can be choice of two-sided, less, or greater. And then for the other tasks, what I did, so again, I wrap it up, packaged up this result into a simulation results class. And then I created some functions, some print function. So print this is simulation results. So when you do print, and when you do print is if it's like a character variable, and then it's just going to print it away as a printing character. But if it prints like the simulation results class results, it's going to use this method and print out nicely the way we want it. So like including some arguments and some data, and yeah. So it's in a concise manner. And then you can do some plotting. Again, this is from the previous exercises. So yeah. You can do some plotting. So we use the ggplots and to create some box plots. Yeah. So let's say we have completed this these tasks. Now let's move on to the next one, and let's look into the quality of this package, and if there's anything we can improve, and what we should do, and what's considered as a good practice. Ensuring quality. So ensuring quality. So apply the plain code rules. So later on, if you see the abbreviation CCR, that means like a clean code rule. And so what you see from the left and the right hand side, they represent the same codes, but with the syntax highlighting, it highlights like the information, the necessary information. But comparing the left and the right, the left hand side seems a bit messy, but the right hand side seems like it's more structured and easier. It's nicer to understand, readable. Why is clean code important? So first of all, it's we consider its maintainability. The code is readable and understandable and has a reduced complexity. So it's easier to fix bugs. Yeah, we don't want to fix bug again in multiple functions. We just want to fix one bug in one function. Extendability. The architecture is simpler, cleaner, and more expressive, and then this is easy to extend to this capability, and the risk of reintroducing bugs is reduced. Performance. The code is often runs faster and uses less memory and easier to optimize. You don't have to consider performance when you're writing like proof of concept, but this is something you should consider in the future and to make the code more efficient. At the beginning, when you design the code and when you first program the code, you just make it run, but then later we can make it like something is good at its production, and let's make it run faster and more efficient. So let's look at some examples, some bad examples, and how we can improve. So the script breaks the common clean code rules. So what sort of rules does it break? So naming, can we improve the naming and make it more meaningful? Like in the previous exercise, we had an M1, M2, and they just like means as mean one and mean two, and make it more readable, like make it English. Computer doesn't read English, but the code is for you and the computer and for other programs to read. So let's make it like use some English to make it more readable. So first of all, the purpose of this function, you can't just like write a function name with y. You can do that, but it's not good practice. It's not good exercise. So what you can do is just say, hey, read the codes and what you're trying to do here. So what's main? What's M1? M1 is just some like we did some summation here, and then we divided by the length of x, and so that's mean one. That's mean. And M2, what's M2? M2 is the median. It computes like the middle points and then computes the median. So yeah, the first rule we apply is naming. We make it more readable, understandable. Yeah, when you read the code, you first you like immediately understand. Hey, it's doing some summations, then division, and then computing the median. Rule number 2, formatting. Are indentation, spacing, and brackets consistent? No, is the code easy to read? It's just like writing English. It's like instead of writing one long sentence with no spacing, no punctuation, and then let's make it more structured. Let's add some indentation, making some structures, making some paragraphs. Yeah. So what we need to do now, we can add in some spaces in between the operations. Yeah. And between the signs and between the brackets and the English, and let's add some space so it's more readable. It's easier to read. Yeah. And yeah, and then we're doing some indentation now. Compare what we had before and what we have now. Instead of like writing your for loop in one line, now we have indentation, right? We're writing it in 3 lines. And yeah. Rule number 3, simplicity. Did you keep the code as simple, as straightforward as possible? Did you avoid any unnecessary complexity? So when you read this code, what can you see? Let's see if there's something like this. It's repeating itself. It's like something reinventing the wheel. And yeah. So first of all, what's here? What's the sum one? Sum one is just a summation. There's already like our functions to do summation. It's just a sum. Taking the sum of vector x. And also, again, you don't even need to divide by the n. You don't even need to divide it by the length of x. Just do the mean x, right? And make it a simple mean value. So you just reduce the number of lines. Before it's 18 lines of code, and now It's just you have it as only nine lines of the code. Right. Single responsibility. That means, does this function do one thing or doing two things? So it gets the mean and the median. So right, it does two things. Since can we break it into two parts? Let's get the mean, and then let's get the median. And for getting the median, and you can write the little condition into another function. And rule number 5, don't repeat yourself. If you can reuse the code, reuse the code. Yeah. So consider examples like this. Result 1, it's like that, and you can compute the result 1, 2, 3, and then just use like one function to do it. And yeah. And for here, what is it doing? Let's see. Get mean. Right. Before it was still doing a sum and then divided by the length. What you can do here is you can reuse the function and just get mean. Yeah. What you're doing here is you're extracting whether it's like the central one number or just two numbers. Yeah, and then get the mean. Next, making some comments, make it more readable, and just explain the purpose and yeah, clarify what it's doing. So adding some comments, returns the mean of x and return the median of x. Next, error handling. We can handle the mean for like a numerical vector and numerical values. But what if someone just making mistake and then get the mean of like the ABC as like strings? What does it mean? So we need to handle errors. So first of all, we need to assert it's all numeric. So you identify whether the error was by your code or wrongly using the function. Yeah. So summary of the clean code rules. So naming, formatting, simplicity, single responsibility, and don't repeat yourself, as well as comments and error handling. That's just something we've mentioned today. And then test-driven development and code reviews. Let's look into test-driven development. Let's do some testing. Yeah, package testing. What's a unit test? Let's consider like a testing. So when we develop Nest packages, we consider like a lots of testing, and we want to make sure the code is reproducible. When you input something, it's going to give you the exact outputs out. So when you testing a function, that's unit testing. You test like the smallest units of a package, and when you're doing this unit testing, you need to consider, hey, just some general cases and as well as some like edge cases and something like extreme cases. For example, like what do you do with a very large number? What do you do when you're dividing by zeros? And zero is something like very often to be considered. And when you're doing this unit testing, when you write this unit testing together and you package it up, and then when you do like a regression test, and then you write like a a small use case and with like an input, and then you put like a script together with like a series of the functions that you executed, and then it's going to reproduce some results, and that's regression test. And when you're doing developing a series of packages together, you can test like the versions between these packages that are consistent, and then that's a more complex case, more complex scenario, and then that's what we call integration test. But for now, let's just worry about it for one single package. What's the smallest test you can write? That's the unit test. And it's typically often written by the developers as a part of the software development process. And it's also like a run automatically as part of the CI/CD pipeline. CI/CD stands for continuous integration and continuous deployment or development. Can be run before committing the code changes. So when you run the code and then you make a test, and then you test it, hey, it's reproducible, it works, and then at least it works on my machine, and then you send it off to the CI/CD. Or we just send it to the CI/CD pipeline, GitHub Actions, and then it's going to use the existing test and to check whether the code has broken anything. Right, why it's important? It ensures the changes of the code base do not break existing functionality. Why? This is very important. When you're developing some code and there's a new feature you want to develop, right? And when you're writing the new features and you're integrating this new feature into your old code base, you don't want to break what's already happened, what's been tested before. This can happen to you when one person is developing this package. It can happen to in a collaboration project. For example, if Daniel and I are programming something together, I don't want to write something that's going to break Daniel's code, or Daniel doesn't want to break my code either. And so that's why we do a lot of like testing, and we want to make sure it doesn't break others' code, it doesn't break any existing functionality. It's expressed for design behavior and the way human can understand, right? So you want to write code that can easily understand, yeah? You don't want to like write a sophisticated example. You just want to say, hey, this function, I give this simple inputs, 2 and 1 as my input. What's the expected outcome? What you could do, you can use some snapshot testing and creating some snapshots that's gonna print out like ASCII code on your screen, and then you can always match it, yeah? So it's gonna help you identify bugs early on the development process. So later on, you know something is working, it's working already, yeah? It's not something you're developing on the downstream, yeah? It can happen from time to time, but if something breaks, you know it's something like it's most likely to be the new feature rather than the old feature, yeah? Lastly, it saves the time and resource by catching issues before it become more difficult and costly to fix. What are the important tests? So I just describe the integration test, and then snapshot testing and performance testing. Testing in practice. So, and in practice, what we do, there's a very, very nice package, and in R it's called TestStat. What you need to do is, considering the examples we given before, and get means is just computing the means. So, for example, if you give the means for 1, 2, 3, and you expect to get 2, right? So this is your actual value at the beginning, and then this is your expect value. So what it does is it's simply just checking, hey, expect equal. This function here is expect to get an output that's equal to 2. That's what it does. When does it fail? Let's test like when it fails, because it's also important to check its constraints and its edge cases, its limitations. So unit test fails when what? When you have an NA provided, what are you going to divide? When you add NA to like 3 numbers. That's an NA, yeah? You're not going to get like a mean is equal to 2. And get the median, yeah? Expect equal 1, 2, 3. And get median is not equal to 2. Why is not equal to 2? What did we do here? If it's a median 1, 2, 3, and why it doesn't work? Okay, well, we'll go back to the exercises later and to see the exercise, the code, and yeah, and test here. But this code failed because of the previous code was defined, how it was defined, and yeah, let's check why it failed. Get the median and the center. Let's quickly check what was wrong here. Okay, let's define our get median. Um, and let's see. Why it doesn't comply. What happened? Something is not right. This is why we should avoid do live coding. Okay. Okay. This one will work. Okay. Right. That means it's not equal to 2. This one fails. That is correct. And this one, it failed because 3 minus 2 is equal to 1. And so the previous function does give you that median of 1, 2, 3. As the median returned as 3. So we find the bug in the get median function. So we go back and fix the function. And hopefully this is right this time. Okay, and we test this again. It gives 2. Now it's correct. So when you do the assertion, when you do the unit test here, now you know this is working. What about the NA one? Let's try the NA example. Yeah, so it handles, it can handle the NA values as well. So what it's going to do, it's going to ignore the NA value. It's just going to get 2 as the result. Cool. So we have fixed the bug and reevaluate the tests. Just did and test that. So test that comparison functions. So there are some. This is just a summary. Give you like what sort of options do you have, and you can do your unit test. So expect the conditions. Yeah, expect the equal what we just did. Expect error. So this is testing. For example, when you when assertion fails and you do expect like the previous example, and you provide get simulated data, and you provided a -1 as your sample size, you expect it to throw error. So when you write a test that unit test, you expect this function to return with a faulty value as an error. Yeah, and the expect false and the true, and that's just for like the true and false for testing the results as a Boolean variable. And test expect greater is it greater than expect value, was greater than or and or equal to. So yeah, you have many options. So LT is less than, and so opposite to GT. And so yeah, many options to use. And you can also test like the class, the type of the variables, the outputs. So when you check this quality of the packages, again, what we're sharing with you today is just like what we're standing on the shadow of giants, and so this is like there's a lot of existing tool already to help you to build these tools. So very often we use dev tools. It's very easy to use. You don't even have to when you build a package, you don't even have to install the package. You can just use DevTools and load all. Immediately, it's going to load all the functions in the R folder and all the scripts, and then into your environment, into your workspace, and then you can run it and test it very quickly. What I'm going to tell you right now is a test is called coverage curve R. As testing the coverage, what's coverage mean? It means so how much of your code has been tested, has been checked. For example, if you have a piece of code that's has 100 lines of code, and then you have a piece of like a function which is 8 lines, and then you have a test that you have a unit test that to cover this function. So out of 8 lines, out of those 100 lines, that's your coverage, and you test it. So that's 8 out of 100. And when you have like so that means majority of the code is not tested. It's not good enough. And you want to improve the coverage. Like as a good practice, people will recommend, hey, if you have tested like a majority of your code, majority of your package, for example, like 80%, that considered as a good coverage. Sometimes you get hundreds, yeah, and that's really good. And yeah, and then there's a code one, and so there's you can do it's like you can create these HTML and to help you to navigate through the code and to show you which lines of the code or which part of the code being tested. For example, if you look at this example and you understand, hey, this line of code, line 229, hasn't been tested. That's why your coverage is not 100%. Code style, again, writing style and making sure like it's like because very often you will have like a lot of people contributing to the same package, but you want to make sure like it's coded written in a similar manner and it's like a readable by others. So this will reduce like the time, the complexity of the code, and so people can easily understand and continue on developing. And it's very nice that there's a R package called styler, and that helps you to do that. In the styler package, it's going to style your text and the style your file. So it's going to detect like the indentation, for example, like making sure it's consistent, and your wrapping, your brackets, whether it has a space before it or after it. And there's like there's a styler file that you can specify your style, and then it can read it. But very often we use the tidyverse style guides and to help us to guide that. And linter R is just something linter to check whether it has followed certain style already. But styler R is just going to automatically in the style code. And also there's like a very nice function as called spell check as from DevTools. It's very easy, very nice to use, making sure like a second language speaker like me, myself, making code that's readable and like also explain the code what it does and to others. So without much spelling mistakes. It does happen, but spell check is not great friends. Right. For styler, you can just go to like as adding from RStudio. You can just go to tools and to adding. Cool. In the interest of time, I'm gonna skip the exercises. And but yeah, please have a look on the web page and go through them, and feel free to reach out to me or Daniel afterwards. Now I'm gonna pass the ball back to Daniel. Thank you.
And we continue with the last part, publication. So the first part we want to show you is to create a very nice website for your package with package down. So that's a very nice way to communicate about your package. Even it might not be yet on cron, but you can still have this package down website. How does it work? Of course, you first install package down into your library. It's also a package itself, of course. And then you can basically use this command again, use package down to get started. So we can quickly try this out. Where is my R session gone? 1 second. I cannot go out here. Oh, I closed it. Yeah, because I restarted to fix my camera. Okay, let's quickly open this again. Let's see if I'm in the same project. This was this. Where is my project? Recent projects, test package. So just want to show you this, how easy this is. Okay, good. So here we are with our test package. So we can say use this and then quickly search for package down, and then there's this use package down here. So it will do again a bunch of things to your repository, okay? And in particular, it will add certain things. So you have this package.yaml that's already opened here, and this is basically controlling the overall look and feel of the resulting output. But let's first go back to the slides. So how does it look like in the end? So when you fill this out afterwards, the main thing is that you kind of build up this kind of reference page, okay? So for example, we can also try to do something similar here in our example. So let's say in our case, we just have this we had this function hello, right? So let's just try to document this function hello here. And here we have some other example from the MMM package. And what does it do in the end? So in the end, it will build up this website that you can basically use interactively to just explore the documentation. You can click on things to look at the help pages. Okay. So let's quickly have a look if this maybe works here. So we've just done this locally now here, right? And we can try, I think, to build this. I think we can do build package down or something like that. Build site, build reference. Yeah, so let's try to build site and see what happens. And it's doing a bunch of things. But just to show you how easy, relatively easy all of this is, even if you want to try this out locally without GitHub, you can also do this. And this can be actually even later when you have a GitHub repository and GitHub pages site, then this might still be useful for some local debugging, this kind of stuff. So let's just go on a little bit. Oh no, something is not good. Okay, but it's still doing something. So you see, it's already building some HTML pages. And then it's saying we have some problem. And you see the problem is that we have this data set A is missing from the index. So then we could, and this is the typical error for package down. You just need to make sure everything that's available to the user is documented. And we can do this just by adding this to this package down YAML file. So this is something useful to keep in mind, even if you do it later in your GitHub repository. So let's try to execute this a little bit in the background. And then the main thing, of course, this will be published as a GitHub page. It's very helpful because whenever you basically update something on the main branch, and this is not part of the course today of the workshop, but whenever you have updates on your main branch, then this will automatically update your website. And you see it actually worked now locally. So I have here now just in the browser opened up my test package thing and have here my reference with these two help pages, and you see it works very nicely, right? So even for local debugging or trying out this works relatively easily, right? Cool. And it's also very easy to push this to GitHub. You can use the corresponding GitHub command. We will, use this command. We will not do this now here because I don't even have a GitHub repository for this package yet. But once you have it, it's relatively easy. And always try to use this commands as much as you can. It will save you a lot of manual work. Okay, so again, this is kind of how it looks like in the end, similar as it also looks locally, right? So this is already a first step towards publishing about your package. Put it on a GitHub repository. We will also talk a little bit about that in a second. And then this package down website really helps to make your package accessible for others. Now let's talk a bit about licensing, open sourcing, and versioning of your package. So when you want to publish your package, and if remember from the chat, maybe not many people have published it yet, but it's important to think about the licensing. So never ever put a package out there without a license, because that makes it basically impossible to use. And you can definitely not put it on CRAN. So always need to have a license. And there's a broad categorization of two very important sets of licenses. The first set of licenses are permissive. So these packages can then be freely copied, modified, and published, at least under the same license. And then the copyleft licenses are stricter. They're the same rights need to be preserved in derivative works. So that means, for example, if you have an MIT license, it's a permissive license. You can do basically many things with this. And you can also, for example, include some parts of the code in another package with another license. Whereas if you use a GPL license, it's a copyleft license. Everything that is kind of derived from it needs to be a GPL as well. So it kind of is a self-preserving license in some sense. For GPL, you also need to have a minimum version. So the newest version is 3. And by the way, R itself is licensed under GPL, so that's also good to know. But for the packages, you can really choose, right? And of course, you might also have even other more rare licenses, like there's BSD licenses and Apache licenses and others. But yeah, think a little bit about it. And if you want to go with one of these standards, I typically recommend this MIT license. Then you can also add this very simply to your package. We can quickly try this out here. So you can say use MIT license, and you see what happens. It does a lot of things. In particular, now in our description file, we have here MIT license. There's also a license file actually created. This is actually funny, because actually for CRAN publication, this is actually not preferred that you have the separate license file, even though under the MIT license, you should actually have this. So there's a little bit a mismatch there. But yeah, so this is what you get, and you might hear then back from CRAN team that they want you to remove those files if you actually don't have any restrictions compared to the base MIT license in there. Okay. Yes, and the other important thing is, of course, when you think about using other software, other packages. So whenever you bundle any code from other software, right? Whenever you go somewhere in a package or in a software or in a website or anything, and you somehow copy paste some code from there into your package, you need to be very careful. So you must be careful that any copyright and license statements from this code are preserved and authorship is not misrepresented. So what you must not do, you must not just go to some random Stack Overflow post or other package GitHub repository and just randomly copy paste stuff from there into your package and just don't say anything about it. That's not okay. Okay. You also need to check if the licenses are compatible, right? Again, as I mentioned before, you can, for example, not copy paste code from a GPL package and publish it as an MIT package. That doesn't work. That's a violation of the GPL license. And as I mentioned, this license file that was populated automatically here by users that can contain further restrictions of the license. Okay, so the open sourcing, how the easiest way to open source your package is not CRAN, is actually to make the GitHub repository public. So we didn't talk about GitHub today because that will be taking much more time, but that's the easiest way. Just put your package on GitHub and have a public repository for it. This allows for easy open source contributions from other developers via pull requests. Of course, before doing that, you need to check with your organization. Are they okay to publish the software? What is the appropriate or copyright holder or who? Right. So typically, if you're employed by a company and you produce code in your company time, then the company will be the copyright holder and funder of the package. If you do it in your free time, then it can be yourself, maybe. The good thing is that if you have it on GitHub or similar platforms, Git platforms, that also allows bugs to be filed and to have issue pages in the package description mentioned, right? So do I have an example for this? No, I don't have. So what does it mean? So for example, there is this kind of you can have this URL field here, right, where you would basically enter the GitHub address, right? So here you would have, I don't know, github.com/ and then repositories or something, and then whatever is the website, right, for your package. And then there's another field, I think it's called bugs, but we can check let's quickly check. I always forget what it's called. Let's quickly check, for example, a real package here, MMM. So bug reports, yeah, sorry. So you then have this bug reports field, right? And then you basically tell the user if they find any bugs, right? Um, whatever, something like this. Then they need to go here to file the bugs, right? And this, of course, works with any other kind of platform, website, like RForge was there in the past and so on. You can also put this here, but then this makes it very easy for users to know how to report bugs besides just sending you an email, right? Okay. Versioning, I mentioned a little bit about this already in the beginning. The version field defines the package version, of course. And I also mentioned this already. Maybe one thing that is kind of interesting is, sorry, is this kind of last fourth set of digits. So this is also connected to some kind of conventions. So typically when you are on GitHub, when you are in the development version, you might make this very obvious for the user by having this 4 digits field at the end after the patch version. So this is kind of the development version. And then the good thing about this is that you can count this, you can increment this as you're making your commits, for example, on the Git history, right? So with one commit or pull request merge, you could always increment this last number here by 1, and that would identify which development version somebody's using. And that's also quite useful as a convention. Okay. Okay. Checks before release. So what do you need to do before you want to release your package? Let's talk quickly about cron, because that's still one of the most important ways to release a package. Cron is the central repository for our packages. And there was a very nice talk at this year's Use R conference. I think the recording is also online already. Please check out YouTube. By Kurt Hornick talking about cron. So has a long impressive history, and this repository has additional requirements beyond the standard package ones. So what does it mean? So you can have a valid R package, but it's still not okay for cron, right? So it has additional requirements, and these are described in the cron repository policy. And whenever you submit a package to cron, then you need to indicate agreement with the policy. Okay. So where do you see this? So for example, when you look for cron submissions, and you want to submit a package to cron, then you will actually see here already on the first landing page, you will say you are familiar with the rest of the cron policies. And then when you click on this, then you see all of the cron policies. Okay. So if you're new to cron submissions, please read through this one time. It's not that long, so it's kind of reasonable to ask to read this. And let's just quickly close this here. And in particular, one sentence is very famous. And the sentence is that the time of the volunteers is cron's most precious resource, and they reserve the right to remove or modify packages on cron without notice or explanation. Although notification will usually be given. Okay. So there are a couple of things in here. So all of the people working on a cron team, they are volunteers. So they have other jobs, often at university, but maybe not always. So they kind of do this in their free time in some sense. Okay. So we need to be very, very careful that we don't waste that time. And then second, as soon as you kind of submit your package to cron, you're kind of at the mercy of cron maintainers. Okay. So they might remove your package if you don't follow certain instructions. They might modify it and so on and so on. That's kind of what you agree to when you submit your package to cron. Okay. Very important for cron is you can only submit source packages. Okay. So that means you cannot pre-compile certain code into binary format and submit it. That doesn't work. In particular, though, RDA files, which is the R binary format for data files, this is allowed because this can be kind of opened by R and then read, and they can check if there's some malicious code in there and so on, right? The other important thing is for cron, you need to have a single designated maintainer, and that must be a person, not a mailing list. Okay, so what does it mean? So here in my little test package, very important that one person has this creator role. So that means it's the maintainer. I would be the maintainer of this package. And I'm a person and have an email address. So this is kind of required by cron. There is also additional contact field, but I have never used this, to be honest. So I'm not sure how realistic this is. In my experience, also very important for cron reviewers is that you use some kind of citations in the abstract, so in the package description, followed by the DOI reference. So that means somewhere in here, this text will be, of course, much longer. You will probably need to have some kind of references to some other work. Okay, there might be a statistical methods paper, there might be another package, anything else that you kind of build on or relate to or use or implement or something like that. So better have something like this in there. Also, it's very important that you reduce the runtime of test checks, examples, vignettes, compilation, and so on. Okay. So there are certain thresholds that you must not exceed. And when cron checks your package, unfortunately, the cron servers are much slower than your usual laptop because they're running all kinds of packages in parallel, of course. They're busy 24/7 with checking packages and building packages. So really try to reduce the runtime as much as you can, right? If there's really something running very long, you might need to factor this out. You might need to use this kind of skip on cron thing from teststat. Maybe I can quickly show how this looks like. So when you have your tests, right? Let's say you have a test here. Let's make a quick test. Test fun2. And usually I use the convention here, test, and then the file of your original code. So let's say we want to test this stuff, what we had here, this hello function, okay? Then we say here, test that works correctly or something. And then here we would have to test, right? So here we would have a lot of code, takes very long or something. Code. Let's say the code takes very long. There is an option that you say skip on cron. And when you have this kind of command here, then whenever you are on cron and then this test would just be skipped, right? That's of course not the super ideal way, but sometimes you have to do this kind of thing. Otherwise, you need to provide cross-platform portable code for cron. So the cron runs checks on Windows, Mac, and several Linux distributions that you might never have heard before. And you need to make sure this stuff works. So we will talk about how to do that in a second. Then also be mindful of the fact that a cron submission can take a while. It's not a matter of a few minutes, right? So for example, one of the packages RPact has developed It's also called RPAC. That took quite a long time for submission, and there was some painful experiences in there, right? So, for example, on Linux, things were behaving differently. Then there was some nodes that also led to rejection of the package. So definitely also try to remove all of the nodes from our command check, right? Try to fix everything as much as you can. This is already mentioned. Your laptop must be much faster than cron checks systems. Don't use the package R package 4 in your package title. Okay, so that's a detail, but they don't want that you say here. I mean, even this is already not very good, right? So they want rather something like this where the package thing doesn't appear here in the title. Okay. And then description of the package must be provided with a DOI reference. This is what I just mentioned. So somewhere in here you want to have some DOI references. Okay. So how do you make sure your package runs on different operating systems? Yeah, either you have all of these machines at home in your basement or something, but probably not. So there we have this RHub framework, which is very, very useful. So most recently, it started to work with GitHub Actions. So again, also here, it's important to first put your package in a GitHub repository. And then you can use this RHub setup for setting up the GitHub action that basically um, sets up these GitHub action definitions in your repository. Then, of course, you push this change in a commit to your GitHub branch, to your main branch, for example. And then you can afterwards just trigger these checks with RHub check. Okay, and then they will start checking on Windows, Mac, and Linux operating systems. And as long as your repository is public, this does not cost you any money because GitHub has free GitHub action runs for public repositories. If it's private, it depends on your subscription to GitHub. Yeah, talking about GitHub, I mentioned already a lot. What do we need to think about for publication in terms of GitHub? Let's first talk about tags. Tags are actually a feature of Git, so the underlying version control system. They are not specific to GitHub, so they also exist on Bitbucket or GitLab or other platforms, right? Git can tag specific points in the code history as being important. Typically, for each release, we create a tag V and then the version XYZ. So we can have a quick look at the MMM package to see how this looks like. So here we have releases, and I think somewhere we also have tags. Yeah, here we have tags. So you see, there's all the tags for this package. We can just browse this here, and we see this format that I've used. I've just used V followed by the version of the package. Okay, and why is this nice? Because users can later check out the package from Git, from your Git system in the state of this release version, so that they can directly go back to the state of the code base at this commit. Of course, it's not really necessary because in principle they could also use this Git hash of the commits, but of course, remembering B874528 is more difficult than remembering V0313, right? So that's in the end all that it's about. And of course, in R, you can use the remotes package, for example, with install GitHub or install GitLab and so on, and then point to your repository and then give the tag reference, the tag as reference, and then you can directly install this version, right? It's also nice because you can compare versions more easily, etc. So tags are useful. When you do a release, always also tag your commit. We went through that already. So releases are based on Git tags. That's a feature of GitHub. It's not so useful in my experience. Yeah, I can show you here. I mean, it's useful in the sense that you see the description of the changes, which is basically from the news file. But the actual assets here, which is the zip and tar.dz and zip file and so on. I mean, in principle, normally you would not really download this here directly, but you would just use remotes, a package to just download it more easily. So in my experience, this is not so much used, at least for R packages. Of course, if you have other things, for example, the latest positron, development version, that's another thing. Then this will be really used, these assets here for download, right? Okay. Quick word on Bioconductor. The Bioconductor project develops, supports, and disseminates open source software for the analysis of biological assays. And like CRAN, Bioconductor has additional package requirements. One interesting difference to CRAN is that packages on Bioconductor are peer-reviewed by community members. So it's more than just a technical check. These reviewers will really go into the contents of your package and check whether this is actually a new valuable contribution to Bioconductor or not, right? And another interesting difference is that it's not like CRAN, where you basically have updates all the time, 24/7. But here, at Bioconductor, new packages and updates to existing packages, they are only released semi-annually, so every 6 months. Okay. So there's basically in April and October, I think there's the time where there's a new Bioconductor update. So different philosophy there as well. And the software is expected to be interoperable with other Bioconductor packages through the use of common data structures and infrastructure. So that means, for example, I don't know, if you have some RNA-seq data analysis in your package and you don't use the existing data structures for RNA-seq data that are available in Bioconductor, the reviewer will probably say, well, you have to use those and not come up with another version of data structures. Okay, so here are some helpful references as in all the other slide decks. So please have a look at these yourself. A lot of good material there. Okay, this was the license again. I think we're doing well in terms of time. So let's quickly check. So there's some discussion in the chat, but that's good. I guess Joe can answer any immediate questions. Yeah, there's also PAC, exactly. That's the newer thing. CRAN versus just GitHub. Yeah, that's a good question. So usually, I would say in pharma specifically, right? There's a lot of companies that are still very anxious and careful when it comes to just GitHub packages. You have some additional quality checks and requirements, as we talked about for CRAN. And in particular, things on CRAN are checked against malicious code. Things on CRAN are checked to be working together with the other versions of the other packages that you're using, right? And of course, easier to install, exactly. So you can just use install.packages. Everybody knows that, right? So that's why if CRAN is an option, usually it's a good idea to just do it. And benefit from this additional, let's say, integration testing with the other packages that you basically get for free there, right? So, okay, cool. So let's go to the last part, conclusion. Okay, so first of all, interactive part. Please enter in the chat what new skill did you learn in today's workshop. So anything new that you can take away from today as a kind of learning. I would be curious. We would be curious to see what that is. Okay, maybe take your time. I will already continue. I hope there is something you learned. I hope this was not all completely known already. Good. So let's just continue for the sake of time. But please enter something in the chat what you learned. I would be curious. Good. So what do we go through in terms of contents? We first had a look at the R package structure in the beginning. So remember that an R package source is basically just a folder structure with a lot of conventions. And with modern tools like Eustace and Roxetin 2, it is very easy to start a new package from scratch. Packaging a set of functions is an ideal way to share with collaborators and the public. And of course, it's like always in life, good to start small and simple. And over time, you can learn additional tricks and options and make things more fancy. Then we talked about the engineering workflow. I think it's very important. I think too many people directly jump into the coding when they start a package. So I think it's very important to start with a clear write-up of the idea. So that means to have some kind of design document. Okay. So because the design document, you can then also align on this contents with some other colleagues, with some customers or managers or people, yeah, basically other stakeholders, right? And only once that is aligned and once that is clear and once that seems like a good idea to everybody and different options have been evaluated, strategic options, then jump into the programming, then jump into the execution mode. And you can also, we didn't talk about this today, but you can also use agile techniques to break down the whole big mountain of work into small, sizable bits of tasks that can make your life also much easier, and then jump into programming those little tasks, right? Then we talked about the quality checks, of course. So very important to always directly have the tests associated with each of the functions that you implement in the package. And then the last step is then the publication. So like this, you will not waste time on maintenance too much. You will be faster with the release to your customers or on CRAN, and you will fulfill the quality requirements of yourself and stakeholders. Another starting point is that you have some one-off scripts that you repeatedly use. So also those you might want to use in a package. One part of the quality checks is also to use assertions for all the arguments that will lead to better user experience in terms of quick and specific error messages, because in R, many things can otherwise trickle down a lot in the stack and cause very, very unreadable error messages, unfortunately. We didn't talk too much about this, but of course it's useful to implement common generics that R users are familiar with, like print and plot, especially if you have objects defined in your package, either in S3, S4, R6, or S7 or something. So it's quite, in those cases, it's quite useful to try to fit into the R ecosystem with these generic implementations. Yeah, ensuring quality is very important. So definitely apply the common clean code rules, right? And definitely use teststat or TinyTest as an alternative if you want to have less dependencies to test your functions enough, right? Of course, not too much, but you really want to have sufficient tests to make sure the stuff works and to make sure that when you change something in your package, the stuff still works, right? You can use cover to measure and to then later improve the test coverage of your package. You can use styler to optimize the code styling automatically. You can use linter to check the format of your code. And yeah, and then there's all these clean code rules, of course. One is don't repeat yourself. And yeah, so this is very important to keep your package on the repository maintainable and extensible, and also yeah, in some sense also implicitly you might also get better performance. Yeah, for publication, we mentioned package down, how it can help you very easily to create a nice website for your package. Versions and licenses along with news updates are important. Oh, I didn't really mention the news too much. Let's quickly, very quick look again at the news. So it's also very easy to start, right? Definitely always, you should have always a news file. So you can use this use news md command from use this. Which will get you started, right? And you see here, it already says here development version, because why does it say development version? Because I have this 9003 here, right? And then you can further edit this. Again, useful examples here, MMM, but of course also many other packages. But you can also structure this a little bit, right? When you look here at the code, you have the package name, then you have the version, right? This is actually here the development version of GitHub. That's why you have the 9001 here, but this is the release. Then you might have a subsection bug fixes, you might have a subsection miscellaneous, you might have a subsection new features and so on. You can structure this a little bit freely, but some structure is useful. And definitely make sure that those updates are really relevant for the user, right? You don't put any kind of internal, I don't know, internal typos or something that you fix there or comments or something, but really things that are visible and important for the user. Okay. GitHub helps you with checking of release versions. Exactly. Then RHub helps with checking your package before cron submission. Okay, so closing remarks. Thanks a lot for listening. I think it was quite a lot of content, so it's good that you have all the materials online. We will also in a couple of weeks, hopefully, but no guarantees, have the recording for you online on YouTube on the RN Pharma channel. If you want to keep in touch, reach out to Joe or myself via LinkedIn or GitHub. If you have feedback on the topics, format, and content, please reach out. Of course, if you want to give a similar course in your organization, feel free to do so. Just follow you can make a fork of this repository and then just use the license appropriately. That's also possible. Possible next steps, as I mentioned, you can bring this back to your organization. You can start building your own package, share internally first. Then later publish it, for example, on GitHub and submit it to cron. Learn about more tips and tricks how to extend R, and we had a lot of references in the slides throughout, and also on the website of the workshop. And just checking if there's any more comments. Yeah, exactly. This will be posted on YouTube after a few weeks, I think, because it requires some manual processing. Yeah, so then there's always the question, the trade-off, should you depend on another package or not? Yeah, so that's always a case-to-case decision, of course. Yeah, so and thanks for adding your thoughts on the learnings. Okay, great. Any last questions before we finish? Okay, good. Okay, then thanks everyone. I hope you enjoy the rest of the RN Pharma conference, maybe in particular the APAC track. We're excited about this first year of the APAC track. And yeah, hope to see you soon and keep in touch. Thanks everyone. Thanks Joe. Thanks Smitha as well.
Thanks, everyone. Thanks, Daniel.
Yeah, you can just search on GitHub and LinkedIn for us. I think you will find us. But you also have the links in the slides as well. Yeah. Good. Okay, thanks everyone. Bye-bye.